It just makes me giggle every time, Paul. It makes me giggle. I don't even want you to change it to Bob Brindley. I want to keep it at Robert Brindley. Robert Brindley. By the way, this is for my wife. Welcome, everybody. My coworkers enjoy my intro enthusiasm, and I've gotten some notes. And so I'm very excited to be back with everybody on Tanzu Tuesday. That means it's Tuesday. It's 1 p.m. It's exciting. We've got another incredible guest today. She's putting her audio all together. It's so much fun. It's all happening live here, Tanzu Tuesday. And with me, as always, is our good friends Tiffany and Paul.
Technically, it's you, and then me. Oh, wait, now it's me again.
Oh, here we go. Here I am.
Sorry. I'm here too now.
Yay!
Hi.
Hello.
So welcome, Cora. Thank you for joining us.
Thank you.
We're excited to have you here. And some people don't know, Cora has joined the Advocates team for a 3-month stint, and we don't want her to go. So today we are officially putting out there the hashtag Cora must stay an advocate. And we're going to make it blow up the sector because we just love having you as a part of our team.
Awesome.
And you sharing all your knowledge. And so this is another instance where you can share.
Thank you.
Yeah, VMware's got this really cool, like take 3 months and go join another team program. And so we're going to steal you. And that's it. So I don't know who your previous manager was, but they're going to lose to Tasha because she's the mother of dragons and she can pretty much get whatever she wants. Right, Tasha? Hi, good to see you, Tasha. Speaker video not showing, Spencer says.
Which speaker?
I can see you.
Which speaker, Spence?
Oh, he might be...
Just Paul. I guess he just sees Paul.
You only see Paul?
Yep, only Paul.
Tasha.
Oh, well, that's probably for the best.
He does have the cooler of the backgrounds, and his hat, as we found out, matches his TARDIS. So he's inside the TARDIS. Oh. Well, let's talk to Cora while we're. Let's do some housekeeping maintenance. Tomorrow, everyone. Tomorrow ends the submit a talk for Spring 1, which is again going virtual this year, September 2nd through the 3rd. So if you have a talk to submit, head on over to spring1.io, submit your talk. Tomorrow is the deadline, May 20th. And then if you just want to go, register to attend. And there's a button for you to push on there again. So spring1.io, submit a talk, register to attend. It's going to be an amazing 2 days. Tons and tons and tons and tons and tons of spring awesomeness coming your way. We also, speaking of spring, since we're on the spring theme, tomorrow starts our Spring 1 tour, the virtual tour. Normally we travel it around the world, and sadly we can't do that, but we're going to be doing a once a month, the 3rd Wednesday and Thursday of the month will be dedicated. So tomorrow, May 20th and the 21st, we're going to have 2 days with Jakob and Nate, Jakob Pillamon and Nate Shuda. They've both actually been on the show previously. So they're going to be talking about cloud native technologies, cloud native architecture. And so they're going to have some presentation stuff, and they're actually going to have some hands-on stuff. So that starts at 9 a.m. Pacific Standard tomorrow morning. Go to spring1tour.io to register. We have 1,200 registrants so far. It's exciting. It's awesome. So there'll be a few hours on Wednesday of learning and some hands-on stuff, and then come back on Thursday. We'll do some Q&A. And so that'll be really awesome. And then again, we mentioned this first time last week, VMware, the Tanzu developer site is up. So tanzu.vmware.com/developer. Go join the community, learn and share and research as much as you can about all the ways to build better software and deploy it and run it faster, safer, and more securely.
So, Bob, we're going to actually have to start from scratch because Sweet Killer 9 only just showed up. I feel like it's important.
Yep. We're back. Well, Sweet Killer, welcome. Thank you so much Good to see everybody already joining on the chats. Are we back to, is it, are we actually, I'm looking to see if we're off
It's
Paul.
your face?
It's my face. I see my face.
We're on the right thing now.
Okay, we're on the right thing. All right. Yay, it's working. So now let's get to Cora. Cora, welcome. Where are you right now in this world?
I am in New York City, which I hear from everywhere else sounds like the worst place to be, but it's not so bad.
You're looking outside and birds are still chirping and the sun is shining.
I know. Actually, you do actually hear more birds chirping.
Well, I'm glad that you're safe and healthy. Your family, everybody is safe and healthy. Good. So when did you get your start in this software game? What kind of led you down that path?
Well, I graduated, not to date myself so much, but I graduated basically like a little before like the crash of was it like 2001, like enough before that, like computer companies were hiring everybody and their brother. Because I studied
or their sister
in college,
in your case.
Or their sister in my case, yes. So I studied chemistry, but I kind of realized kind of halfway through college that I liked this computer stuff. And so by the time I was graduating, I was just applying to the same jobs the engineers were applying to. So I just ended up at a software company actually, and I've been doing that ever since.
Well, that's wonderful. And I know, but I'd like you to share a little bit. You are originally from Bolivia. I don't know I mean, I think you might be the only Bolivian that I know. If you can Bolivia that. Sorry, that's a dad joke.
That's good.
So talk to us a bit about growing up in Bolivia and how you made your way to the States. You're in the Heights moment. Sorry.
Right, exactly. Yeah. I mean, growing up in Bolivia, I mean, it's a beautiful country. It's a very interesting place. It has a lot of folklore. So it was a really lovely place to grow up. And my parents had grown up there. So my grandparents had arrived from Europe in the 40s. So we were, I was sort of, I guess, the third, you count that first generation? So I was the third generation there.
Okay.
But my parents, so they graduated high school there, but then they went to college in the U.S. and then they moved back. So they always had some sort of attachment to the U.S. And my mom's parents actually, when my mom finished high school, they moved to New York. So that's my connection to New York. So I grew up kind of spending summers up here. And so it was sort of like a natural step for me to just think about coming to the States for college as well. But it was cool. And my parents aren't there anymore. So they're in the States now. So the last time I went back was probably 9 years ago, but it really was a wonderful place. Like if anybody has a chance to visit, it's a very special place.
Do you still have your Bolivian passport? And
I never had a Bolivian passport because my parents, after they finished college, they went to live in Mexico for 5 years, and I happened to be born in Mexico. So so while they were in the States, they got their they were here for like 9 years. They got their U.S. citizenship in the 60s. So by the time that I was born, I was born to American parents. So I've always had a U.S. passport, which has made everything for me easier in the U.S. I have cousins who they have a harder time. They have visa issues and whatever. And so I've sort of escaped all of that. And recently, and then when I was like 5 years old, my Mexican passport expired and we were no longer in Mexico anyway. So, but just like a few months ago, I met this girl who works at the Mexican consulate, and I just mentioned that, it crossed my mind before to get a Mexican passport. So now I have 2 passports, but not a Bolivian one.
And this is why I was kind of asking, because Paul also has, do you have 2 or 3 passports, Paul?
I have 2 passports.
Okay. He's also an international.
Are they different or is one expired?
They are different. I have an Australian and a British passport. The British passport used to be really useful.
Right.
Late last year, it became a lot less useful.
Right.
Now, I haven't been to Bolivia, but I believe one of my favorite cookies is from that part of the world. And I'm going to pronounce it badly. Alfajores?
Oh, alfajor. Alfajor,
yeah.
So, but it's Argentinian.
Oh, yeah. It's Argentinian, is it? Okay.
It's Argentinian. Yeah, there's a very famous brand called Havana that makes them. They are probably the biggest exporter, but there are more and more like artisanal ones and other brands. If you go to Argentina, there's like a million brands, but the biggest exporter is a brand called Havana, the classic yellow boxes. Yeah, they're awesome.
Nice.
I literally, I went to Argentina, and I kid you not, I spent $150 on Havana alfajores to bring back and like have.
Wow.
That's what happens.
Now,
That's what
if
happens.
you're ever
Yeah.
in Chicago Airport, one of the Rick Bayless takeout restaurants has some really good ones that are made locally in
Oh, nice.
Chicago. Torta Frontera, I think, is the name of the place.
That's a United terminal.
I think you could make them, Paul.
I have actually made them before.
Oh,
Not
nice.
nearly as delicious as ones I've bought, but they're pretty good.
Well, I'm happy to see all these people joining us. We got Java Grunt. We got the great Richard Seroder, who's jumped on. He's asking Paul what names are on your passports.
Oh boy,
A bit cheeky, eh?
I could tell you, but then I
Right.
would have to do the needful.
Yes, understood.
I
and also,
don't like making threats on the internet, so I'll just
right.
leave it there.
Richard, I want to take a moment to say, in front of all our millions and millions of viewers that are watching live right now, that congratulations on the next chapter in your career. You will be greatly missed on our team at VMware, and so a solitary tear falls down my cheek.
Yeah, we miss you already.
Yeah, I miss you, brother. And so, again, it's not goodbye. It's as I like to say, as He-Man would say, good journey. And so that's a little Masters of the Universe for you.
and let us know if you have trouble finding the door, and we'll open it for you.
It's right.
Or keep it closed. Don't leave.
So, all right. Thank you so much, Cora, again for joining us. I'm going to now stop talking, incredibly enough, and we'll let you proceed with talking to us about containers.
Okay, awesome. So
Yeah, just do the share screen. And away we go.
Okay. 1 second, share. All right, make this small. And okay. So we are here to talk about creating production-ready containers. And let's get started. I'm going to do like a brief intro. I know a lot of people already know the context for containerization, but just in case, just to make sure that we're all starting from the same spot and in the same mindset, I'll do that. And then we'll talk about Dockerfile, Dib, and Paketo as 3 very different ways to go about creating containers. So first, an intro. So this is probably a very familiar workflow, right? You have some code, you build your application artifact, and then you deploy it to a virtual machine or a cluster of virtual machines that are prepared for the application, right? So that means that, for example, like take Java, you would build a jar file or a war file, and then you deploy that to VMs that have an operating system, a JRE, maybe an app server, maybe even some shared libraries and configuration. And with Kubernetes, that paradigm changes. And all of those dependencies are now packaged as part of that deployable artifact. We have a new deployable artifact. So the question is, why are we shifting these things left? And the reason is we want to be able to deploy and run software in a repeatable and reliable way across computers. And the way that we achieve that is precisely to package all of the dependencies with the application. We want to do it in a standardized format so that we can run it on this standard container runtime. So that's our task, right? That our task is to build this new deployable artifact called an image. And then we can, and we want to do it in a standardized way. So there's the Docker or Open Container Initiative specification. And then we can take that image and deploy that to a container platform like Kubernetes. And that's what containers are, right? They're running instances of our images. So there's different tools in the ecosystem that can help us package an image from our applications. Dockerfile is basically a way to write a script to do it. And then there's higher level tools. Dib and Paketo are 2 examples. And so we'll look at 3. There's more obviously in the ecosystem, but these are the 3 that we'll look at. And just as we're going through this presentation, keep in mind the factors that we want to optimize for. So we want our builds to be consistent, whether it's over time in the same application or across teams, across applications, We want to make our builds fast. We want our image sizes to be small, like to not contain more than they need, essentially. We want to take into consideration security concerns. And then especially if you think about enterprises that are operating at scale and have to manage images over time, you want to be able to provide governance and transparency into the contents of your images. So let's get started. Okay, so Dockerfile, we're going to cover some basic Dockerfile commands, how to launch an app using tags, the build context, shutting down, the internals of an image. We'll look at how it's constructed, and we'll talk about caching, who the runtime user is, and keeping that image size small. And I'm going to do this by way of a demo. So we have a sample app here and a couple of sample Docker files. So basically, we're going to do this using a Go application. It's a pretty simple app. If you run it and don't give it any parameters, it just gives you some usage instructions. And then if you run it and follow those instructions, like let's say you say world, it gives you back hello world. So straightforward. So if we're going to turn this into an image, we need a Docker file. So here's our first Docker file. So you can see that just the general structure of it, right? Every line begins with a valid Dockerfile instruction. And you don't have to capitalize them. It's not actually case sensitive, but by convention for readability, these Docker instructions are capitalized. The first one is this from instruction, and it essentially sets the base image. And the base image is just something to build on, right? Like the way that you would deploy and expect an operating system to be there, maybe some tooling. That's what we're doing. And so for this application, we need a base image with Go tooling because we're going to build our application and then run it. So we need something that will support building and running a Go application. So we happen to be able to pull this image from Docker Hub that's publicly available. So we can just refer to it by name. A label is another Dockerfile instruction. We're using it just to add some metadata. Sorry for you hear the sirens. I'm in New York, but so the label is a way of adding some metadata that can be used later for like filtering or searching and just inspecting your image. The workdir instruction creates a directory and it CDs you into the directory. So once we issue that instruction, we're in this directory that we're creating called /workspace, and we're just doing that to keep our work separated from the rest of the stuff on this operating system. So then we just copy all of our files over and we run go install, right? Typical Go workflow. The go install, because this environment is set up for Go, the go install will put the executable called hello for this program in the path. And so we can just refer to it by name. Now for launching the app, you can use one of two commands or both together. There's entry point and there's command. So entry point will always be launched. So we're saying for our entry point, we want our hello program to always be launched. So the user doesn't have to know the name of this executable, right? They run the image and this will go. You can also add arguments with the entry point. If you don't have an entry point, then command can do exactly the same. It can launch a program and you can add arguments to within the same command. But if you use it in combination with the entry point, then command is simply supplying default arguments for the entry point. So in this case, we're actually changing the default behavior, right? Before we would have gotten usage instructions if you just run the program. And here, if you just run the image, we're actually going to issue hello world and change that default behavior. So we build this using the Docker build command. And the Docker build command expects an argument that provides the context. The context for this application, so that copy ... is basically copying files from the context into the image. So that context has to contain our source code, right? It happens to be we're in the same directory as the source code, so we can just say dot to say that our current directory will serve as the context. And then we just name our image. This -t stands for tag. So if we run that, you can see right away that we're downloading this base image. It defaults, since we didn't prefix it with another registry name or another sort of repository name, it defaults to downloading from Docker Hub at the library namespace or library repository. And that location is actually holds a set of curated images that Docker refers to as official images. There's other sources of images. You just have to make sure that you're getting it from a trusted source. If you're at an enterprise, your enterprise might provide one. So now we've downloaded that image. You can see we've also downloaded a package. Our Go package uses a string util thing to put that fancy box around the message. And our image is ready. So where's our image? The Docker images instruction gives you a list of images on the daemon. So it's placed the image on, it's pushed the image to the local daemon. And you can see that our Golang base is there also. So in the future, when we repeat this build or when we build any application that uses that same base, it'll just pull it from the local daemon. We won't have to wait for that download from Docker Hub. And you also see the image we just built. And you can tell by the size that our new image is basically the base image plus our application. So we can run this just saying Docker run and the name of the image. And you see we've overridden the default behavior, right? So the entry point was executed and the command arguments were provided as default arguments. And if we supply a different argument at the command line, then the entry point is still executed, but the command is overridden. So the command functions as a default, right? So let's talk a little bit about tagging. You can see, so the images we have so far, the tags are latest, right? Latest is the default if you didn't specify any tags, but tags provide information about either the version or the variant. And so we want to be able to communicate more through the tag. So we're going to go ahead and tag. We can use the Docker tag command to tag our image as, let's say, version 1.6, and then we'll assign it a second tag that's more generic. We'll say it's like version family 1. So once we do that, we can look at the images again. And you can see that the ID is all the same, right? So these are just aliases to the ID. And if we rebuild, so any kind of change we make, whether it's to the source code or the Dockerfile, we'll change that ID. So we're just going to simulate a little change we're going to make a change to the default command. And then we'll rebuild this. And in rebuilding it, we'll assign it version 1.7. And then we'll also move the pointers for version 1 and latest to this new image. So if we look at the image again, you can see that the 1 and latest have moved to this new ID, but the 1.6 is still pointing to the old one. So this helps users of our image choose the best tag for them, right? If they're in prototyping or if they're in development, maybe they want to use a more generic tag so that they can pull the newer image when you'd have to delete it from your local daemon, but you can pull it. Whereas if you're building something for production and you want to guarantee that no matter what machine you're building your image on or what point in time, you always get exactly the same image, then you want to choose the most specific tag. So again, conversely for our own image, right? We also want to pull. We're not just creating images with tags, but when we pull, this would be a case for, let's say, production, where we want to be very specific about the tag that we're pulling. So with regards to build context, we mentioned that the build context has to provide all of the files that the Dockerfile needs in order to build the image. Now, what we didn't mention is that the build is not happening in our local directory. It's not the CLI that's actually doing the build or running the Dockerfile. The Docker CLI sends all of the files in the context to the Docker daemon, and the Docker daemon executes the Dockerfile. So there's evidence of this. If you just run your Docker build, the very first line of output says sending build context to Docker daemon. So we're sending here almost 18 kilobytes of stuff, right? So let's run our image. So we can look inside. We can override the entry point. We can force override the entry point by specifying the flag. So instead of launching hello, we're just going to launch the shell. And we're using that -IT flag to make it interactive. The RM just removes the container when it shuts down. So let's run that. And that drops us into the container. So now that we're there, first of all, we can see what directory are we in by default. And you can see it's /workspace. So that /work, that work dir instruction that we had in our Dockerfile not only does that create a directory and cd you into it so that you can execute the rest of the commands in the Dockerfile, but it also sets the default directory. The last worked or instruction in your Dockerfile will determine what directory you're in when you enter the image. And we can also see what files are here. And we've got, you know, a few files we don't need on the image. We wouldn't want to send files we don't need into production, right? So number one, it adds bulk. And second, it kind of creates this loophole for confidential files to accidentally get in there, maybe a malicious file. So that's something we want to fix. And thankfully, fixing that is very straightforward. There's a .docker ignore file that you just need to place in the directory. It's very much like a .git ignore. It just filters what gets uploaded. So here in this example, we're excluding everything by default, and then we're saying we want to allow these three files only. So now that we've got our .docker ignore file in our current directory, we can rebuild, and even just from the sending, you can see that it's sending less. And we rerun that entry point. This time, the entry point's on the left of the image name, and you can pass arguments on the right. So the -c says we're sending a string. We'll just do a listing, and you can see that there are actually less files on the image, right? So it's smaller, it's safer, and it's easy to do. So, okay, so next topic will be app shutdown. So how does your application know when to shut down, right? So if you do like a Docker stop on your container, or Control-C here if you're running the container on the foreground, a signal is sent to the container telling it to stop down and telling it to shut down. And the process that receives that signal is a process that has an ID of 1, which means it was the first process to start up on the machine. So every process has a process ID, right? But process ID 1 has some extra responsibilities. It is the parent or grandparent, et cetera, of all other processes. And it has to be listening to the kernel or the container system for these signals and pass them on to child or grandchildren processes, right? So if you have a good PID1, it'll catch the signal, it'll forward it to other processes. Once that gives processes a chance to shut down gracefully, essentially. And once processes shut down gracefully, then PID1 shuts down, and then the container can exit, right? If that doesn't happen, if you're doing, for example, a Docker stop, Docker will wait maybe 10 seconds for the container to shut down, and if not, it'll just kill everything forcefully. So that takes away the opportunity to do a graceful shutdown. So this is why we want to be aware about whether or not our processes are catching it. So in our Dockerfile, we have our entry point set to hello, right? So our entry point is going to launch the hello program. So that is going to be the process with process ID 1. So the question is this process listening for that signal? And you know, if it is, then it'll shut down. So we'll run it, and I'm going to add this environment variable just to enable a sleep that's built into the app. And just to test this out, I can do Control-C, and it shut down, right? So here I'm basically relying on the Go tooling to produce an application that is responsible in terms of like listening for these signals, right? So that's good. And generally you can rely on, I think Node maybe not so much, but like Java will do it, et cetera, right? So it's not that we have to do much more than that, but it's good to check. Now, sometimes you want a more complex entry point. For example, you might use a shell script, or just use shell to launch hello and then do some fancy stuff. So for example, here we're using the shell to capture multiple arguments that are provided by the user and put quotes around them. Now, the shell is not a good PID1. It listens for signals. It does hear the signal to stop, but it doesn't forward it. So it won't tell hello to shut down. So if we rebuild our image using this new entry point and then run it again, number one, you can see, I didn't have to put quotes around rising stars, right? So that shelled quoting is working. But here's, so I have 90 seconds. So if I Control-C, nothing's happening because it's not, shell is listening, but it's not telling hello to shut down, so the container can't stop. So just to show you here, if I do a Docker PS, I get a list of the running containers, right? And I gave it this nickname. It can be assigned a different nickname, but a random nickname, but just to keep it simple. So then I can do a Docker exec and then the name of the container, and then I can run a command. So if I want to list the processes inside of the container, you can see here that the shell is PID1 and hello is a child of the shell, right? So we couldn't control C it, but we can say Docker stop, hide, and takes whatever Docker waits for it to kill it forcefully. I think it's about 10 seconds. But then hello didn't have a chance to execute any kind of graceful shutdown that we would have coded, right? So how would we solve this? There's two solutions. There's two approaches. And generally, in a container, you want to keep your containers to one main process, right? It's not like you want to start a process that spawns 5 other things. So this approach should be appropriate in most cases, which is just to prefix your entry point, the call to the program with hello, with exec, sorry. So here we are calling hello through the shell. And if we use exec to launch hello, what that does is it elevates hello to PID1. And then we know that that will work, right? We've seen that working. So that's often enough. Now, there are cases that, as I mentioned, I believe it happens with Node, but sometimes there's cases where the shell might pass, the process itself doesn't listen. Like if you do this simple test with sleep, which is not a realistic use case, but if you do it with sleep, if sleep is PID1, it doesn't listen to the system for signals. So in that case, the other solution is to use a special wrapper to be your PID1 that will act that will wrap your entry point. So there's one particular one called Tinny, which is init backwards, that has been built into Docker. So you actually can enable it by just adding this ---- init flag right into your run command. And then this environment variable tells it to send the signal to not just its direct children, but the grandchildren. So if you had shell, hello, and then asleep, this would make sure that Tinny sent the signal not just to shell, but hello and sleep and down the chain, right? So so you could enable it like that. But then if you deploy your container to Kubernetes, you can't do a Docker run there. So what you would want to do is actually build this into your Dockerfile. So let's look at that. So here you can see that now we're using Tinny to be the main process. So Tinny will be PID1. This is the same as that environment variable, saying don't just to send the signal to the children, send the signal to all of the whole group, all the grandchildren and so on. And then here is our entry point moved over to the right. We can now use the shell to do some fancy stuff because Tinny will take care of sending the signal to hello. We don't have to rely on shell. Now, if you are familiar with Dockerfiles, you might be looking at this Dockerfile and saying that is not a good Dockerfile, and you would be right. But to understand why it's not a good Dockerfile, let's talk a little bit about layers and caching. So the Docker history command gives you a history of a particular image. So let's look at the last image that we've built. And you can see that an image is not one thing, right? It's actually composed of layers. Each of these lines is a layer. The bottom ones are layers that that came from the Golang base, and the top ones are layers that we added. And you can see here on the right that each layer corresponds to an instruction in the Dockerfile. So you can think of a layer as a git commit, right? So every instruction in the Dockerfile is doing a git commit essentially, or doing a commit to in the form of a layer. So that's the nature of a Docker image, right? And then the other thing you can notice here is that in the created column, these layers have different ages. Even the layers within that we added through our Dockerfile, starting here, they have different. Oh, not the bottom one, not the 3 days ago, but these top ones. They have different ages. So that means that's telling us that we've run our Dockerfile, we've run our Docker build command 3 times, and each time Docker was intelligent enough to realize that there were layers created in previous builds that were the same and that nothing had changed. And so rather than create a duplicate, it can just reuse these layers. So the layers form a cache for future builds. Once a layer is invalidated, once there's a difference, whether it's in the source code or in the Dockerfile, or even in the file, this one, for example, we just copied some more sample. I think this was maybe copying sample files to the directory that maybe the Docker ignore. I don't know. Even if the context changes, as soon as the Docker daemon realizes that there's a change, it stops using cached layers, and from there on forwards, it starts creating new layers. So with that understanding, let's reevaluate that last Docker file. Okay, so generally, the problems that we're looking for break down into three main categories. One is the order of commands, one is the grouping of commands, and then one is what is all, like for every instruction, if you think of it as a commit, what is the contents that are being committed together? So here you can see, for example, in this copy ... we're copying all of the files from the context very early on in our Dockerfile. This means that any change that we make, right, whether we're changing source or we're changing the modules, we're basically going to invalidate the cache at our third instruction before we've done anything meaningful. So we're going to be reinstalling this Tiny OS package and re-downloading our Go modules and then rebuilding our source code probably every time we run a build. So we definitely want to move this down a bit and separate the code from the modules, because the code will probably change more often than the modules. Then if you look at these instructions, we've actually separated the installation of this Tiny program into two steps, which means that if we decide to add another package, Tiny and something else, we would bust the cache at this layer and possibly be running this install on an outdated apt-get update layer. So we actually want these things to always run together. So there's a few other subtle improvements we can make, but we'll look at an improved Dockerfile. Okay, so here is a better Dockerfile. So you can see that we've moved the instruction to install Tiny higher up the stack here, because chances are that the OS packages are not going to change very often. And we've combined the update and the install. In fact, we're combining everything that has to do with the installation of this package into one command. So it'll all be one layer. Because we're committing it as one layer, we also want to make sure that that layer is no bigger than it needs to be. So we are adding this no install recommend so that we're not installing unnecessary things like documentation. And we're also removing the package cache right before we commit the layer. Next, we are breaking down our copy instructions and first copying the file that has to do with the modules, so that utility that puts a box around the hello world message, and later copying the source code. And so before we copy the source code, we actually download the module. So now we just copy source code, we don't have to re-download those modules. And we leave this, our most frequent changing layer, for as late as possible, and simply recreate the binary, the executable after that. So this will be much better. We can time it. So I'm adding time here at the beginning and then saying no cache, so that this build will build without reusing any existing layers. So you can see here we're installing Tiny. This JSON is the download of the Go package, and it took just under 10 seconds. And then if we simulate here a code change, or make a code change rather, so here in the program, we'll change the setup below, it'll be greetings. And then we'll rebuild that. And you can see it's all pulling from cache, right? Using cache. It only stops using cache when we copy the source code, right? Here's using cache, and then no more using cache. And it took 2. So a lot better. Oh, sorry, I'm just cleaning stuff up. Okay, so let's talk about the user. Let's use this syntax again that we used before. We'll override the entry point. We'll call the shell, and we're just going to use ID to see who is the default runtime user. and you can see that it's root. Now, being root inside the container doesn't mean that you have root privileges on the host VM, but it's still going to make it easier for a user who gets in to maybe explore the network, find other services over the network, or a very savvy hacker could actually maybe exploit an operating system vulnerability and gain access to the host. So the reason that it's root is because in the Golang base image that we used, that's the way it was left. The default user was set to root, right? Because we didn't set the user. So we're inheriting that configuration from whatever was the default user on the base image. And being root on a base image makes sense, right? Because you get a base image, you probably want to install packages on it, but we're creating an application image. So it doesn't make that much sense. Our application doesn't need root access. And really we should be following the principle of least privilege. So luckily, there's a very easy fix for this, which is there's a user instruction amongst the Dockerfile instructions. And if you just set it to an arbitrary ID, it'll change the user and it'll change the user permissions. Now, there's more you can do, but this is sort of table stakes, right? So if we rebuild, and then we'll check that again. So you can see we're now a different user, right? And on the same sort of topic of security, let's talk about image size a little bit. The main motivation for trying to minimize the size of your image is actually security. It's not really efficiency. Efficiency is when you pull an image or you push an image for the first time, you are pulling or pushing the whole thing. But thereafter, if you make changes and pull or push, you're really only sending the changed layer. So more so than the size of the entire image would be the importance in terms of performance of sending updates over the network is more the size of a layer that changes frequently. So the main motivation really about concern over the size has to do with security. So because you don't want to put more stuff into production than you need, right? So here we've got our image, and we said before already that our image is just a little bit bigger than the Golang base. So most of this bulk is coming from this system that we really needed to build the app. We don't need all of that stuff to run the app. Now, what you need in a base image for runtime, of course, depends on your application, right? If you're using Java, then you need a JRE and so on, right? But if you're using Go, you really could just package your application as a standalone executable so that it includes the utility that we're using, the module, and then it's just one executable that you run without having other dependencies. So because we're in that situation, we can really pare the size down. So here's the way you do it. This is called a multi-stage build. So we said already that a from instruction creates sets the base image, right? The other thing that the from instruction does is it initiates what's known as a build stage. So here we have two build stages. The first one we're using to build the application, and then the second build stage we're using to release the runtime image, right? So we've removed everything here that doesn't have to do with building the app. We've changed our build command a little bit so that we're building it in the standalone fashion rather than having the package separate from the executable. We don't need Tinny anymore here. So, and then in our second one, when we copy, instead of copying the source code, we're copying the built executable binary, and we're copying it from the /workspace directory, which is where we know it'll be. And we use this from flag to say, rather than copy it from the context, we're copying it from, and we use an alias here that we created up here. If you don't have the alias, you could just say stage-0. And this is stage 0, this is stage 1, but it's a little more readable with aliases. And then because we're in the situation where the binary, the Go binary doesn't have any other dependencies, we can actually use this special quote unquote base called Scratch, which is really nothing. It doesn't download anything. It doesn't add an image. It doesn't add a layer. It's a way of saying don't add anything to the image. I don't need anything, but still initiating, being able to use the from instruction to initiate a new stage. So, right. And so, and because we're using this super minimal approach, we don't have, a container operating system, so we don't have a shell. So we have to give up that shelling to combine user arguments. So let's rebuild that. So it's just building right now. It's building the standalone binary, and then it's done. So first, let's check the size, and you can see how much smaller it got, right? And it's a lot more secure this way because you don't have all this extra stuff that you actually don't need. And we can just double check, make sure it works. We have to quote our arguments ourselves since our shell won't do it, and it still works. So that's Dockerfile. Everybody still awake?
I'm silently clapping.
Yes.
You're doing good.
Awesome. Okay.
This is
Good. Okay.
We're all
Okay, good.
actually
Awesome.
amazed at your use of BAT. I think a few of us hadn't seen that before, and our minds are kind of
Oh.
blown.
Thank you. The BAT-D, I actually I wrote a function, and then I have the function alias for BAT-D to compare two files and highlight the differences. But it's been fun. But thank you for noticing. I appreciate that.
Yeah, we were actually in chat discussing how we thought you were doing BAT-D if it was an alias or something. But yeah, it's
an
really
alias
awesome.
to a function. Yeah,
Nice.
I can share it. I just can't share it won't come up if I just do alias. But thank you. So we've covered a lot about Dockerfile, and you can see Dockerfile is like a double-edged sword, right? You have a lot of control, but you have to learn all these low-level details, which is kind of the opposite of what we want, right? We want to make things easier and have people focus on value rather than have to go back and learn all these low-level details. But Dockerfile obligates you to do that. You have to, for every instruction, you kind of have to become an expert in that little field. So, but anyway, we've learned the basic structure. We've learned how to launch the app, the difference between entry point and command. We are how to use tags effectively, how to minimize that build context. We've looked at shutting down the app and two possible solutions when your app doesn't shut down, and layers and caching, how to look at ordering, grouping, and what you're committing as a group into one layer. We looked at changing the runtime user, and we looked at minimizing the size using a multi-stage build for efficiency partially, but mostly security. So that is it for Dockerfile. So I'm going to move on to Jib. And so Jib is a tool that was introduced by Google in 2018, and it's for containerizing Java applications. So we'll talk about some of the benefits, how to use it, how to configure it, and we'll go into a couple of the features in more detail. So the benefits of Jib are, number one, it's simple to use. It doesn't require a Dockerfile, so you can forget everything you've learned so far in this webinar, and you don't even have to have a Docker daemon or a Docker CLI installed. So it makes it easier for example, for a CI toolchain, and it's provided as either a Maven or a Gradle plugin. So because of all of those things, it's very easy to just integrate it into an existing Maven or Gradle workflow. It's also fast. It includes some optimizations for build speed and for application startup. And it guarantees reproducible builds. So the same input will give you the same image. So let's go into a little more detail to understand better. So first of all, the easiest way to try out Maven is to try out Jib. And the other thing is I'm going to use Maven, but obviously the documentation for Jib is on the GitHub site for it, and you can find all of the Gradle equivalents. But the easiest way to try it out is to just put the fully qualified name right in your Maven command, and if you can choose this build goal, and the build goal will build the image and publish it to a registry. So in that case, you have to give the image a name and specify the registry, the repository, and the image and tag. There's also a Docker build goal. So if you do use Docker, and if you have the Docker CLI and the Docker daemon, you can choose the Docker build goal. And you can give it a name. If you don't give it a name, it'll just use the artifact ID and the version from the POM file by default. And there's a third goal called build tar, which produces a tar file in your target directory called jibimage.tar. And then you can use Docker load to load that into your daemon. And then that when you load it, the image name is the artifact ID and the version. So 3 different goals that you can use. If you don't want to type this much, which I wouldn't, you can, of course, like any other plugin, add it to your Maven POM file, and then it simplifies the command. And if you don't want to call out the compile and then the jib goal, of course, you can just add it to the lifecycle, and it becomes part of your Maven package. So super easy to incorporate. Now, in terms of some of the performance optimizations that we mentioned, so jib does not use Dockerfile. So this is an illustrative Dockerfile. It's from the FAQs in the jib documentation on GitHub. But this is what would a Dockerfile look like for a jib built image. So we can see a few different optimizations. So for one thing, you can see that it's not running a jar file. It's running an unpacked Java application. And just unpacking a Java app can improve your startup time by like 30%. So that's done by default. The other one is this layering. So it's taking advantage of Docker layering. And what's important here is if we take a step back and talk about the way that Docker pushes and pulls images. When I mentioned this a little bit earlier, but like if you have an image and you pull the image and the whole thing gets pulled the first time, but then when you pull a new version, only the layers that change get pulled, right? Or if you push, only the layers that change are pushed. So what jib is doing is it's organizing the application files and then committing them in different layers in order of their likelihood to change. So same concept of layering that we saw with Docker, jib is applying that to the contents of the Java application and saying basically that dependency jar files are least likely to change, right? You're going to change your Spring Boot version once every few months. So that's not going to change much. And then snapshots, if you're using snapshots, the snapshots will probably change more than the other dependencies and so on. The ones that are going to change the most often are the class files. So first it organizes the files and then it copies them to the right directory at the end, but in different layers. So if you think about a situation, for example, where you have, say, thousands of edge nodes, it's much better, since these are separate layers, if you just change a few, some source code, you can just basically transfer a few kilobytes over the network to the thousands of edge nodes rather than maybe like 100 megabytes, including all of your dependency jars. So that's a big improvement also. And the third one is that it uses a main class to launch the application. It's not launching with the main class as compared to unpacking the jar is very meaningful in terms of startup time. The main class is not as meaningful, but it still includes this optimization. And if you can set that jib container main class variable, and if you don't, then jib will infer it on its own. So these things, I mean, maybe separating the Java files is a little more complicated, but otherwise, you can build these best practices for Java into your Docker files as well. But jib is doing it automatically out of the box for all Java applications. The other thing we talked about was reproducible builds. So if you look here, here I just created the same image, same source code, same configuration, absolutely no changes, just built it 3 different times. And just to make the example a little bit more clear, I built it 3 times with the 3 different goals, and I tagged it like that. So each of these was built from the same source code using the same configuration, just a different goal. And you can see that the IDs are all the same. So that's the guarantee of a reproducible build, is that as long as your inputs are the same, your image will be exactly the same, meaning that it'll have the same digest, right? The digest is a hash that we use to uniquely identify an image. So that's the guarantee that and it's not only that we use, but that systems use, right? That Kubernetes, for example, would use. Now, notice here that it says created 50 years ago. So the reason for that is that in order to achieve this reproducible build and ensure that these 3 images are generated to result in the same hash, jib has to blank out or make standardized, I guess, right? Replace in a uniform way any timestamp. So whether it's the last modified or a last created timestamp on a directory or the actual image created time, in order to achieve reproducible build, those timestamps all have to be the same from one build to another. So you can override that in Gib. Actually, they do give you an environment variable or a tag for your POM file where you can say that you want this, but then you'll give up the reproducible image IDs, right? Can't do both. So, okay, base image configuration and debug. So the base image that Gib uses by default is called distroless Java, which basically means that it only has what's necessary for a Java application to run. You just add your code and that's it. It doesn't have a shell. It doesn't have any other utilities that you might expect on an operating system. So it makes two things more difficult. Number one, if you have to install any packages, like, maybe not Tinny, but maybe there's something else you would want on your operating system, you can't do that on the distroless because it doesn't have the apt-get, for example, the apt-get install. And also, if you want to debug, it doesn't even have a shell. So those things are kind of hard. So if you do want a base image that has certain packages installed, you basically have to create your own, and you can replace the default using these from image tags. If you just want to do a little bit of debugging and you just need a shell, the distroless Java actually has a variant with a shell, and you can get it by just adding the debug tag at the end, and then you can shell into it using the busybox shell. And then I think the last thing here is the configuration tags. So you can change configuration for a Gib built image through your POM file, essentially. There's a container section that you add to the configuration of your Gib plugin. And for example, we saw a label, we were setting a label with our Dockerfile. This is the way you would do it here. The default user on the distroless image is root as well. So unless you change it, you're going to be root. It does come with a special user called non-root that you can just reference, or you could just put an ID here. And then there's also, there's a directory source main Gib. If you might have seen it in the Dockerfile example, but any files in your source main Gib directory get copied to the image, just not in the class path. It's a way to get other files in there. So if you are running a Java agent, for example, you could throw it in that directory and then use the JVM flags to configure that, right, to enable it. And there's more. There's other configuration options. So that's Gib. So you can see that for Java applications over the past 2 years, it really has provided a great resource so that for developers not to have to deal with Docker files. In some cases, not having to have Docker is useful. It's seamlessly integrated with your Maven and Gradle flows that has these optimizations built in. And then it has some negatives, right? Like the configuration is all basically baked into your POM file per application. So it's hard to share that. There's no built-in mechanism to share that or to reuse that or to standardize on it, et cetera. And then it has this catch-all directory for adding agents, but that's it, right? It's just like a folder, and then you have to set your JVM flags. But it's definitely easier than Dockerfile and more standardized than Dockerfile. So that's Gib. Still, okay. Still haven't lost people, right? So quiet.
Yeah, we're all
Okay.
still here.
Still here.
Okay, good. Thanks.
I've learned things.
Awesome.
Java Grunt said that you were doing amazing, and he feels upgraded.
Aw, thank you. Oh, I can see part of it. I have the chat on a different computer. I can't do two things at once, but I will definitely go back and read all of it later. But I appreciate everybody's support and participation here.
You focus on that, we'll tell you that you're doing great.
Nice. So, okay. So now Paketo and cloud native build packs. So I'll explain what the project is, what Paketo build packs are, some of the benefits. We'll walk through an example. So the cloud native build packs project basically aims to make it more standard and easier to build applications from, or to build images from source code. It's a project that was initiated by Pivotal and Heroku in 2018, and it provides an API defining this platform to build pack, and we'll explain exactly what that is, contract. And it also provides some reference implementations, right? So it defines a specification, but it also provides some implementations that we can use right away. So the two main concepts here are platforms and build packs. So a platform is a tool that you use to use build packs. So for example, Docker CLI as a tool that you use to run Dockerfiles, right? So the platform is the thing that you interact with. And because this is an API-based ecosystem, there's more than one platform, right? As long anybody can write a tool that conforms to the platform specification, and you have a tool. And those tools can provide different kinds of user experiences and satisfy different kinds of needs. And then there's buildpacks, which are basically the components that provide the language runtime support. So all of the logic that you would have provided through your copies and your runs and like exactly how you're building your application in your Dockerfile, all of that is now built into these modules called buildpacks. And because they're modularized, it's easy to use some in some cases and some in some other cases, et cetera, right? And to share them, and they're all cleanly packaged. So it's a way of adding behavior while ensuring that it's manageable, auditable, repeatable, reliable. Now, as far as platforms, I mentioned there's an ecosystem of them. Pack is the reference implementation for a CLI from the buildpacks project itself. Spring Boot has recently, in the 2.3.0, which was GA'd just I think last week, it includes support for Spring Cloud build for cloud native build packs. Kpack, I think Kpack is also a reference implementation from the project, if I'm not mistaken. But it's a hosted service that, if you're familiar with like Cloud Foundry or Heroku, and you just push your app gets built somewhere in the cloud and then deployed as a container. That's the Kpack experience, but on steroids, because this whole project is sort of a generation and advanced. And then there's others, and there's a growing ecosystem. In terms of build packs, there's also a growing ecosystem. This Google one just was released a couple of weeks ago. Heroku and Pivotal, as I mentioned, have a long history in creating and in fine-tuning and in supporting at enterprise-grade build packs. And so the Paketo build packs are actually an evolution of the Cloud Foundry build packs, and then you have Heroku build packs as well. And those are open source options. There's some commercial options. VMware Tanzu in particular offers a superset of Paketo. And this ecosystem, I think, is also growing. So some of the benefits is that it's a very easy way to build images from source code in a variety of languages. So it's not just Java, but a broad set of popular languages. And within each language, the way that the image is put together follows best practices for that language. So we saw that Jib applies some best practices for Java. With cloud native build packs and Paketo, you would have, with Paketo in particular, you would have the best practices applied for each language. It also has optimizations for the use of cache, and there's like a whole sort of cache management system in the background that says more to do than just the layers, but rather even sharing of layers across applications. And it's an API-based model, so it makes way for a growing ecosystem to address different use cases. And this modularization of functionality. So as we saw with Jib, if you want to add an agent, you throw a file in there, and then you have to configure your JVM flags. But with this model, because build packs themselves are modularized, you can actually create a module that adds a particular agent, and then that can be easily reused in a standardized way, plugged in, plugged out across an enterprise. You have the same concept of reproducible builds, so you'll also see that your images are like 40 years old. I think it just uses a different base for that, but the same concept of reproducible builds, and that's true across. If you have different platforms, right? You have one that's a hosted service, one that's a CLI. The same way that we saw with Jib, that using 3 different goals produce the same image. With this system, if you use a CLI versus a hosted, you would get the same. Whatever platform it is, the result will be the same. The same code inputs, the same build metadata, you'll get the same image. And you have transparency. It provides some additional ways to do some inspection into your images. There is a Docker inspect command that you can use on any image, but this also provides some additional inspection. And these are actively updated. So when there's patches or releases in upstream language runtimes or the OS, then you get these through new releases. And there's a very cool mechanism to, if you just need to change the operating system, this would be like changing the from command in your Dockerfile, right? There's no way you can change the from command and not invalidate all the rest of the cache. But in this, same with Gib, right? So you, in the case of cloud native build packs, there's a mechanism to just change out the operating system layer without having to recreate the image. So that's really powerful if you think about a situation across the enterprise that's like Heartbleed or Spectre or something, and you've got thousands of images and you just need to change the operating system. This actually does it. It just changes a pointer in metadata, and that's it. You've rebased your images. You just redeploy your images to your container system. So it's incredibly powerful. So let's look at this by example. We'll use the pack build command. We'll use pack for this example. But this command that you see on the screen would produce an image at the end. So the first line is the pack CLI, which, as I mentioned, is a reference implementation for a CLI. And that comes from the Cloud Native Build Packs project itself. Pack has a few different commands. So here we're using the pack build command. And all we're doing is giving the image a name, right? Pretty straightforward there. Of course, we need to provide our source code. So we can use the --path or the -p flag to say, here's my source code. We need a runtime image. So we were using, in our Dockerfile examples, we were using the Golang image initially, and then we switched to Scratch. We saw the distro list is used with Gib. But in any case, you need some image that you're going to use you need some base image that you're going to use for that image that you release for your application, right? So that's our base image. Oh, I'm sorry, I got these backwards. I'm not looking. So the builder is the build time image. So that would be, so in our last example in Dockerfile where we had the multi-stage build and we used the from Golang to build and the from Scratch to release, the builder is actually like the from Golang. This is your build environment. So it is very comparable to a multi-stage build. Okay, so the builder is that. The run image, the next one, that's the base image that you release. So this would have been like our Scratch, right? Or this is the distro list, right? Because Gib is just building it. Gib doesn't have a separate environment for build time. It just does the Maven compile of your source code, and then it just copies stuff into the final image. So this is that final image. And then there's this set of these modules that one are executed in order, one after the other, that will produce your application, your file. So here you're starting with source code, for example. So you can see that this would have been a Maven application. If it would have been a Gradle app, then you would have pulled the Paketo build packs Gradle. So they're pluggable in that way, right? This happens to be Spring Boot. If it wasn't Spring Boot, you wouldn't see this one here. So they are combinable, composable, based on what kind of application you're building. Now, this is a lot to type, and you can see that everything from the builder down is actually all coming from Paketo. So Paketo provides the build packs. It's an implementation of the build packs, right? The Cloud Native Build Packs project provides the specification for build packs, and then Paketo actually provides the content. So Paketo has the intelligence about how to build a Java application or how to build a Node application. And the Cloud Native Build Packs project provides a way to put these things together and churn out an image. So we can see that all of this intelligence, including that run image and that build image, we're getting all of that from Paketo. So, and Paketo by itself could actually figure out, based on your application, which build packs it needs to use and in what order. So it doesn't make sense for us to have to figure this out for every application that we build. And so actually what's done is that all of that intelligence is just packaged right into that builder base. So that's why it's called, I guess, a builder and not a build, because it's more than just an image on which a build is composed, but rather it's a builder that has all of the build packs and can figure out which build packs do I need for this app and go ahead and build it. So we just need to reference the builder. And even the builder, we're probably going to be using the same builder over and over for our apps. So why not just set it as your default builder? And then just for kicks, we can actually CD into the way we would do for a Maven package, right? We just CD into our code. So then we can actually just simplify the command to pack, build, and the name that you give your image. And it's that simple. It'll work for Go, for Java, for Node, for .NET, and there's more. And that ecosystem of frameworks can also grow because all you need is some build packs that know how to handle that particular language. So it's incredibly powerful and very elegant. So where does the image go? It does go to your local Docker daemon. So that's maybe one advantage. If that's important, then Jib doesn't have the dependency on the daemon. Actually, you can publish, but you still need the daemon. But you can publish the image. You can use the ---- publish flag and publish to a remote registry. You just have to, if you're credentialed, so if you do a Docker login first, for example, for Docker Hub, then when you do a pack build, you add the ---- publish flag, and of course you'd have to prefix it, right? So it knows where to go in Docker Hub. But that's it. And so you can see that it downloads both the build image to be able to detect what your app needs and carry out that build, and then the run image, which is the one it's going to release in the image that you deploy to production. As far as configuration, so here it's also very clean. It's all done through environment variables. So every build pack is going to check the environment variables and either use them. So for example, if you set BP Java version 8, by default it's 11. If you set it to 8, then the build pack that provides the JRE is going to know that you want a JRE of version 8. And so that's what it'll do. This one, for labels, like this build pack, actually, it's on GitHub, but it's going to be integrated in the next release. Right now it doesn't add images, but it will soon. But basically, if you just set these environment variables, then it'll add labels to your image. So you can set arbitrary labels, or you can actually follow the OCI has some convention on the labels that you might want to use. And so it's got those built in. So you just set the environment variable. If you want to set debugging enabled, there's a build pack that actually will configure things for debugging, including so you can attach a debugger. In Jib, you would have to do all of that yourself. So you'd have to update maybe create a profile in your Maven POM file and then set it all up for debugging. And here, all you do is set up this environment variable, and you're trusting that the build pack has taken into consideration the different settings you might want for debugging, and that it's sensible choices. So you just turn it on. This is by default, for example, it runs a Maven test skip. It skips tests by default. So if you wanted to change the Maven build and maybe run tests or do anything different, you could change it, and so on. So, and then these environment variables, actually, when you build an app, usually, I think it's becoming in the Java build pack for sure, and hopefully across them it's standardized. But the output of a build actually tells you what environment variables that build pack uses, and otherwise it's also documented on every build pack has its own repo in GitHub, so you can also check there. To clear the cache, it has its own clear cache command. So let's do a demo of that. Oh, I forgot to do this. I'm sorry. Let me just let that run for a second. So while that's running, let me just go back to, it's going to set up, I'm just going to pre-build some stuff and pre-download some builders so that the demo is a bit faster. But while we're doing that, maybe I can pick a few other slides here. Yeah, let's talk about this one. Okay, so we mentioned that this modularized nature of the build packs makes it very easy to provide a way to add agents. And so, in particular, I think this might be where you start to see commercial things. So you might need a license to use a particular agent, and you can also see this is building on this ecosystem that Cloud Foundry already had with integrations through the build packs with different companies. But all of that logic is available through this particular commercial set. But there's no reason that in the growing open source ecosystem as well. This basically Cloud Native Build Packs project is providing you a way to provide agents very easily in a standard way that you can share across the organization, across the world, really, right? So we looked at the Pack CLI through slides. I'll show you in the demo the one with Spring Boot as well. And I'm just going to show you here the KPack, which is that hosted version. So KPack is a platform that you install, that you deploy to Kubernetes, and then it does similarly to Pack. It has to know what source code you want to build, right? And it has to know what builder you want to use, and it has to know what registry the image should go to. So if you give KPack those 3 pieces of information, then it will constantly be, every 5 minutes, it'll pull the Git repo and say, has there been a new commit? Has there been a new commit? If there's a new change to the code base, then it will automatically build the image again. It also monitors the builder, and it says, has the builder been changed? Or you could actually, so you could separate that it's pulling the run image also from the builder. So either one of those. But if one of those inputs changes, then KPack will automatically build the image. So the configuration of this would be, you would, just like we set when we set our set default builder with a Pack CLI, and we told it which builder to use. So you would create a builder resource in Kubernetes, give it whatever name you want, and then just say, this is the builder I want to use. This is the same builder that we set as our default builder when we were looking at the Pack example. And then for every application that you want to build, you would create an image. And that image has to have, most importantly, what is your code? So here we're saying, here to my app over here, and where do I want to put it? So this is the address of the registry where it should publish the image, right? Because in Kubernetes, you wouldn't have access to the daemon. You wouldn't have access to your local clone, so everything is done over the network. And if you only change, if you take this builder and decouple it between the builder and the run image, and you only change the run image, then what that does is trigger that rebase that I talked about earlier, where it just changes out the operating system rather than rebuilding the image. So that's also available through KPack. So then if you imagine that you've got thousands of containers thousands of images across your organization, and you just update the run image, then KPack will automatically, within seconds, change the OS across all of your images, and then you just redeploy that, which is, it's incredibly powerful if you think that there's companies that, how long it took, months in some cases, for companies to update after operating system vulnerabilities are found. So, okay, let's go back to the demo. All right, yeah, so I just built things so that you don't have to watch like Spring libraries download and the builder and stuff download. So, okay, so in this directory, we've got a Go application, same Go application, a Java application, and we have a sample build pack. So first of all, we can set our default builder so we don't have to type that. So there we go. That's our default builder. And then there's a command called, we spoke about inspection. So you can actually inspect the builder itself. And so you can see here that this particular builder would support applications in Java, Node, Go, .NET, etc. That's why it's a good default builder, right? Because it supports a lot of stuff. And you can see exactly what build packs are here. Build packs for each of those languages, exactly what their version is, and which base image that we're going to use for runtime for that final thing we're releasing to production, and some more information, even what's on the operating system, etc. So you can get a lot of information about exactly what you're working with here, right? Let's go back down. So let's go ahead and build it. So pack, build, and the name of our image. We said it was that simple. We're just adding the -p because we're one level up from where the source code actually is. And you can see that it would have pulled from, these are in Google Container Registry. I had already pulled them to my local daemon, so this is really quick. And then it goes into this life cycle. So first it detects, right? So first it says, okay, I have this source code. What is it? And it figures out by itself that it's Node, or that it's Go, sorry. And then within Go, it says, these are the build packs that I need to apply. So if it had been Java, I would say, oh, it's Java Maven, or it's Java Gradle, right? And it would choose the build packs for this particular case. So all of that is built, all of that logic is in the builder as well, right? Aside from the image to build on. And then it analyzes and it says, have I built this image before? And if yes, let me get the metadata to figure out how I can maximize the use of cache. So it gets that each build pack is going to need some of this metadata so that the build pack can figure out if it has to rerun or if it can use what it had cached before. And that's per build pack, right? So in Docker, we had a lot of sensitivity to the order of things, and with cloud native build packs, it's not so sensitive because every build pack can make its own decision about the layer that it had created, regardless of the order. So it restores that metadata, and then it starts to build. And so basically in the build, so here we identified that we want to use 2 build packs. So it goes ahead and it says, here's the first one, and then it executes the second one. Each one contributes layers, and then it exports, which is, releasing that image, and that's it. We've got an image. We can do the same for the Java one. I mean, you can see it's a little more meaty. There's 6 build packs being applied, and it does the analysis. So it includes, it chooses the JRE. It's Maven, so it does that Maven package with no tests, as we saw before. So this is why I prepped before, so that we wouldn't have to watch the Spring libraries download, and it's built. So it's also very quick. Oh, and also you can see here, let me point this out. So my application is using Spring Boot 2.3.0, and Spring Boot 2.3.0 does something similar to what we saw Jib doing in terms of organizing the contents of a Java application into subdirectories based on the likelihood that they are of the change. So again, dependencies are, you can see here, right? Dependencies are least likely to change all the way up to your, again, snapshots are more likely, and application resources and applications are put together here. And these are also copied in layers to the image. So same thing, you have it if you're using a new enough version of Spring Boot. And if you're building Dockerfiles for some reason for Spring Boot, you can also take advantage of this, of course. So we've got our image built. So we look at our images. There are our 2 images, and same, just 40 years ago, different choice of date, but same concept in order to achieve reproducible builds. So the rebase is that operation where we just change out the operating system. So there's a pack command called rebase. So let's rebase the run image from our Go application, right? Just the OS layer that we're using at runtime. So we're just specifying a different version. And honestly, this actually, the way that I'm running it is taking seconds, like up to, I don't know, 8-10 seconds. But this operation is actually under, like, it's milliseconds, and it's just because if you run it on a registry. So if I would add if I had set this up a little bit differently, and we're using a registry for this, and I added the -- publish flag, it would run this on a registry, and it would literally take less than a second. But in any case, it's just switched out the operating system. So even that is pretty fast. If we look at our image again, you can see that here's our ID from before, and we've just rebased it. And of course, it has a different ID because now it's a different image. And KPack, as I mentioned, will do this at scale across all of the images that are using the same run image. So just to sort of explore what best practices are built in. We said that we want not to be root, and then we saw in Jib you have to do that manually. If you check the user in a pack built, in a Paketo built application, it's not the default user, it's a user called CNB, and the group as well is CNB. So that's good. There's also a bill of materials. So there's a inspect command. We already ran an inspect command to inspect the builder and see what we could build with a particular builder. There's also an inspect for the image that we've created. And you can run this without this ---- BOM flag, BOM being bill of materials. If you run it without, you'll get a little higher level information. And if you run it with this BOM flag, then you get a full bill of materials. And then what's in the bill of materials depends on what those particular build packs put in there. So this is for the Java application, and those build packs happen to be including in the bill of materials all of the libraries, all of the dependencies in your application. So you can just inspect it. You can take any image and just run this inspect image command on it and know exactly what all of the dependencies in there are and their version. So very, very powerful in terms of identifying this transparency that we were talking about and this governance across the organization. It also includes like what JRE, closer to the top, I think. It tells you exactly what JRE, so I would know if this image had a JRE of, you know, 8 or 11 or so on. Anyway, somewhere, I think I lost the buffer. Let's show an example. So far we've been using the Paketo build packs out of the box. But let's say you want to build your own build pack, right? There's some libraries that your enterprise needs to always include, or there's something you want to do, or whatever. So you might want to write your own build pack and have that be part of the process. So here is the directory structure of an example build pack that's available also on the Cloud Native Build Packs GitHub site. And you can see that it's got a configuration file, and then it has 2 scripts, a build and a detect script. So this is you can see here kind of the API that a build pack has to comply to. It has to be able to do that detection, right? So in that detect phase where you figure out whether or not a build pack should be run on a particular code base, that's what this detect has to do. It has to look at the code and say yes or no. And then if it says yes, then when its turn comes, then it executes its other script and it does whatever that build pack has to do. So the structure is pretty straightforward in terms of complying with the API, right? So if we want to use this, we can say pack build again. Here's the name of our image, and where's our source code. And so then what we're adding here is saying, listing out the build packs like we saw before, dash build pack or dash build pack. And so we're listing them out and we're adding ours. You can point to a URL or to a directory. And then we're saying, we don't want to, if you only say this, it'll only run your sample build pack. But if you want to run it before or after all of the build packs that you would run otherwise using the builder, then you can place this flag either before or after, and it'll be done in that order. So here we're saying, do all the build pack stuff first by default, and then run this sample build pack. So we can run that again. And you can see already in the list that before we had 6 of 16 build packs, and you can see now it's 7, because it's going to do the 6 that Paketo realizes by itself, and then it's adding our sample. And then it goes down the list, it does all of those, and when it gets to ours, here it is. Hello world build pack, and it just prints out some environment variables. Just an example. So Spring Boot. So if you like that, if you love all of this very powerful Paketo stuff and cloud native build pack stuff, which I hope you do, but you're like, I don't want to download another CLI. You want that Jib Maven Gradle experience, Spring Boot 2.3.0 is now integrated, now supports cloud native build packs. So let's go into our Java application folder and we'll look at the POM file. And I have here my profile. Okay, so this profile right here says use this goal. So it's basically a build image goal in the very familiar, if you're a Spring Boot developer, if you're a Spring Boot developer, your friendly Spring Boot Maven plugin. And then, as we saw with pack, right, when we were looking at the pack commands, the configuration is done through environment variables, so it's very clean. You could just say, these are my environment variables that I'm going to use, or you could point to a file, right? And then this one, the layers enabled is true. Actually, this is what enables when I mentioned the way that Spring Boot can also organize the files inside the jar, so it separates dependencies into a layer and application into a layer. That's how you enable it here as well. So it's very clean configuration, and we can run that. So we'll just say the profile. And so because this is Spring Boot doing it, Spring Boot does the Maven compile first, and then it does the buildpack stuff after it's compiled the code. And that's it. It's executed. You can see the same sort of flow, right? It does the detection, the analysis, etc. All of the same workflow, right? All of this, it's all compliant with the Cloud Native Buildpack specification, just a different implementation, right? Instead of the Pack CLI or instead of KPack, it's just Spring Boot doing it through the plugin. And our image is built 40 years ago. That's all I have. I don't know if there's more slides here.
Hey, Cora, just a quick question about the buildpack stuff, and sorry if you answered it and I missed it, but if I wanted to, say, ensure that all the Spring apps running in my cluster have, say, the Prometheus actuator, is there a way with the buildpacks to, say, like add extra dependencies as it's passing through?
Add dependencies to your POM file?
Right.
I don't know if there's like a Prometheus build pack that would do some configuration for you. That would be something you have to look at different build packs on GitHub to see if there's something specific for Prometheus.
Yeah, I guess I'm more asking it like functionality-wise, that's something that buildpacks would be able to provide. I might just have to write my own build pack to actually do it.
You can write a build pack that adds dependencies for sure. Yeah, absolutely.
Awesome.
Yeah. So that's it. Just a summary of what we saw about the project and Cloud Native Buildpacks providing the spec and some reference implementations. And there's that, it's a fascinating system, actually, the way that it can do the rebase, and that when it does the rebase, it actually, all images on are pointing to one shared layer. So it's very quick also. And that all is built into, there's the reference implementations that come from the Cloud Native Buildpacks project, right? Because they provide the spec, but then there's a CLI, and then there's the logic that's actually doing that detection and flowing through that cycle and doing the analysis of cache and all of that stuff. That's also a reference implementation from the Buildpacks project. So, and that ends up implementing this really fantastic system of being very efficient about cache. So we learned about the builder and the image, the custom build packs, rebasing. We saw the Spring Boot, both the plugin as well as layer jars, which is independent but leveraged here, and KPack. And I think I'm repeating myself at this point. That's it. That's all I have.
You did it. You crushed it.
Awesome. Good work.
Thank you.
Thank you, Cora.
Thank you.
And your last name is fun to say too.
I don't know where to look.
What do you mean?
Iberkleid. Yeah.
Yeah, it's fun to say.
Fun to say.
Iberkleid.
I used to say Iberkleid, and then nobody could spell it, so I switched.
Oh, so is there a proper way of pronouncing it?
Well, now Iberkleid is proper.
Okay, you made it. Okay,
I made it proper.
Well, awesome. Well,
Cool.
Yeah, we had lots of great questions that some got answered by you and some got answered by us, and
Awesome.
So thank you, everybody.
Can I see the chat? Does it get saved, or will it get lost?
I believe it's saved for as long as the video is on.
Oh, really?
Twitch,
so I should
which is
copy
about-
paste it
which is about
before.
2 weeks.
Oh no.
Yeah, so it might be a good idea.
Oh, okay.
Yeah.
Okay, it's not like 2 seconds.
No.
Yeah, I'd love to see what people were asking and saying.
Yeah.
Is chat located separately? Because like if I were to join the video again separately, the chat is always cleared whenever I start.
Oh, is it? Uh-oh.
Yes.
Oh, that's right. I've noticed that too. Yeah,
Is
if you
that
come in late, you
something
miss.
on our end where we can, like in our video producer creator dashboard, blah, blah, blah?
Yeah, I'll have a look at
Can
that
one
and
of you
see if
capture
we have
it?
a way to
Oh, there you go.
save it from being destroyed. One of the things I do want to
Well,
work
I'm
on
trying.
is actually have it show up in the live stream itself. Although that's not going to help the presenter because they're still going to be busy looking at their own desktops. So
Correct.
that's still a thing. Now I think
I like how we're
had-
troubleshooting live. Let's
Right. That's
any
how we
other
roll.
things that technically we want to go over while everyone else is with us?
Can I do a little plug?
Oh, please.
Absolutely.
Sorry. So this material, I've been preparing this material so that it's published as a course on the Cube Academy website, which has other awesome material. Oh, that's what I was missing in the slides. I didn't show you this. I didn't show you this. Can you still see my screen?
Yep, we can.
Yeah, right? Okay. So yeah, I had some resources to share. So just generally like resources on containers in general, you can learn more about containers. Also, this one I wanted to show you. So in terms of the Dockerfile, here's some more resources, but I particularly like this one on the Educate's website because I didn't go into security very much for Dockerfile. So the Educate's website has a really great video. So I would recommend that one. And then, Jib's got the Jib documentation on GitHub basically, and Paketo, coordinated build packs. You can have information up from the project, from the spec about the Paketo build packs in particular, about the Spring Boot plugins, or about Kpack, and then you can search for whatever else you want. I think that was it. That is it.
Awesome. Now, before you unshare your screen, is there any chance you can show us your alias/function for BATD?
Oh yeah. Yes. How do I do that? So, where is it? I think I have it. I've recently improved it, so I don't know if I put it here, if I put the improvement here, if I have it in a script. But if it's not here, I'll show you the script. Okay, so not there. 1 second.
Asking the hard questions.
Mm-hmm.
All right.
Well, she's got to search the hardest mainframe of them all, the brain.
Here you go. Right. Okay, there you go. So basically, it's the highlighted argument. I don't even know what I did here, but so the other thing about this is that that I use this environment variable, that language, and I actually then also alias bat itself to be bat minus L with that language because it doesn't always work well. Sometimes to do the Docker ignore, you have to set the language to exclude, and to do the Dockerfiles, well, I think sometimes it detects it properly and sometimes it doesn't. So I also have a set bat alias that will change this. If you say set the bat language to exclude, it changes it to minus L exclude, so that when you get to this part of the instruction, you can actually do bat minus L exclude or minus L Dockerfile or whatever. But basically, I'm just doing a diff, figuring out what lines have changed in the new one, and then using the capability of bat to actually highlight lines if you provide it the beginning and ending indexes. So there you go.
That's some solid bash foo right there. I'm really impressed.
That is some serious OCD.
This is
that's what that is.
One line of bash is to me way more exciting than anything else.
than everything else I did.
No, not just you, but all of us across all of Tanzu Tuesdays. This one line of bash is it's like the cherry on the top of Tanzu Tuesdays.
Nice. Well, I appreciate it because the journey to get there was very long.
Reason number
starting
7,000.
with color diffs, and I had cat alias to take out comments, and then color diff, and then I had side-by-side stuff, and then I finally discovered bat, and ended up here. There's a keeper.
Yep. Reason 7,000 to keep you on the advocacy team.
Right.
Hashtag
keep
Cora an advocate. Let's do it.
Now, another thing I thought I would mention, I mentioned it in chat, but I thought I might mention it now, is a couple of weeks ago, Brian Lyles did a couple of episodes of TGIK, which is Thank God It's Kubernetes, which is streamed onto YouTube. And he did some stuff on using cloud native build packs and Tecton as a combination. And so folks that saw the cloud native build pack stuff that Cora just showed, you might want to go back and have a look at that as well, because that's a good addition to what you've just seen.
Perfect.
Cool.
And we're trying to get him on our show, so hopefully we can get
That's
Brian on our
right.
show too. It's so nice. Also, was there one other thing that we need to mention? Well, oh yeah. Hello, Tiffany. Next week,
Hi.
we got you. We got you on the ones and twos next week. So give everybody a little something to come back for.
Well, I'm just going to give a very high level. Basically, I'll be talking about CF for K8s, so Cloud Foundry for Kubernetes. It's open source. If you want to take a look at it, you can just go Google and find it on GitHub before I end up talking about it. And I'm learning it to give this talk, so it's entirely new for me as well.
Sweet. And yes, Java, it's the zeros and ones. I love what you did there. I love what you did there. I also have been watching a lot of DJ sets thanks to Patrick Gillis, who's a member of the VMware event crew. Anyway, so the ones and twos coming from there. But friends, we did it. We did another fantastic Tanzu Tuesday. Much love to all you who have been tuning in regularly, the Javas, the Sweet Killer Nines, Brian McLean, Richard Seroder, again, tip of the cap to you, fine sir. Tortilla 1999 is back. Good to see you back. Spencer Gibb, always. You're going to be up in a couple weeks. Can't wait for that. So yeah, we got lots of fun people here that have been coming every week. So appreciate it. Tune in next week. Tiffany, we're excited to have you, and it'll be fun. Cora, again, can't thank you enough. This was incredible.
Thank you.
And we're going to get you to stay as a permanent member. It's happening.
Thank you so much. This has been so much fun.
Awesome. Yeah. Take care. Stay safe. And until next Tuesday, bye-bye.
Bye.